In this video, we're going to solve a problem from Introduction of Probability. This particular problem actually appeared in JEE Main 2019. So here it says that we have a random experiment, and in this experiment a fair die is rolled until two fours are obtained in succession, that means consecutively. The probability that the experiment will end in fifth throw, that we need to find out. So let's solve the particular problem. So here we have a random experiment. So what is random experiment? We know that random experiment means it's a one kind of an experiment that outputs are well known at priori, but we don't know what will happen at that particular instant. That's called random experiment. Now, when a fair die is thrown here, right? So therefore, first we observe that what will be the sample space. What is sample space? Sample space means it's a collection of all possible outputs. So therefore, we can easily write down when a die or a fair die is thrown, the sample space is for this particular problem will be equal to obviously 1, 2, 3, 4, 5, and 6. So this is definitely been obviously the sample space for our problem. So that's it. Now here we've seen that there is an event that we are getting for or maybe something else. So therefore we consider that let A be the event, A be the event of getting 4. So what that means here, if I try to calculate the probability of A here, the number of proper event will be or favorable event will be equal to 1 because only one time, and total number of event is 6. So probability of A is equal to 1 by 6. Now also then if I try to find out that A complement, it's actually the event of not getting 4. That means we can get anything except 4. That means we can get 1, 2, 3, 5, 6. So therefore, probability of A complement is equal to 5 by 6, or we can easily obtain it by 1 minus probability of A. That's it. So you obtain probability of A and probability of A complement. Okay. Now see that here it says that the given random experiment, the random experiment. So for simplicity, I write down it as RE, the random experiment is stopped. This is actually the given condition. It's stopped at fifth throw. So therefore, it is obvious that fourth and fifth entry, fourth and fifth throw, we get 4, and between first 3 throw, we don't get 2 consecutive 4. because it's given that if I get two consecutive 4, we should stop. So if I get first entry 4, second entry 4, right? So therefore we stopped it, right? So therefore this condition must be prevailed. Now therefore we consider that 5 boxes, right? So these are the 5 boxes which represent the 1, 2, 3, 4, 5. Yeah, 5 boxes which represent, right, how we get the number in that particular throw, right? So therefore, this I represent that this is the first throw, this is second throw, this is third throw, this is fourth throw, and this is fifth throw. Now, it is obvious that in fourth and fifth entry, right, we should get 4, right? Because then only I able to stop the throwing, right, or the random experiment. So what is the possibility? So therefore, in that 1, 2, 3, as I said, we should not get, right, consecutive 4. So one possibility is that between every event, right, we don't get 4. So therefore it is A complement, A complement, and A complement. Therefore that means in first 3 throw we don't get 4, and then consecutive 4 we stopped it. The second option is that maybe in the first throw I get A complement, in the second throw I get A, and obviously in the third throw I get A complement, because then only we are able to stop that experiment, right? That is the possibility. And the next one is in the first only I get A, and next two consecutively we get A complement, right? And obviously in the other two cases it is obvious that we get it as all A. Now see that if I read it, right, how we say, so these events, right, that in first I get A complement, in the second I get A complement, in the third I get A complement, and so on. So therefore, these events must be written as, right, as a multiplier form, right? So this is actually happened by or connected by the English conjunction, that is and. So this is connected by the and operator, right? And either we'll get the first option, or we get the second option, or we get the third option. So therefore we can say that the required probability in this particular case, right? So if we go ahead and write that let A be the required event, then what will happen? Let's go ahead. So in that particular case, we can easily rewrite, right, that probability of the same probability of these events. So if we go ahead, right, we can write down that probability of A is equal to probability of A complement, A complement, A complement, and then double A, plus probability of A complement A, then I get A complement and double A, plus probability of A, A complement, A complement, then double it. That's it. So this is the required event. Now our job is to calculate this event. Now, to write down this, we just remember one thing: when the two events A and B are connected by AND operator, it's actually go ahead, we can write in a multiplication form, or when it is a OR format, it should be addition. Okay. But here we can also write down, see that if I observe that, right, we are talking about that two events, right? So in the 3 events and 5 throw, here it is there. Now in the first event, right, I am getting the 4 or not 4, right? In the second event, getting 4 on node 4, right? This will be independent event. So the probability of getting 4 in the first throw doesn't depends on that what will happen in the next throw, or the next throw doesn't depends upon the previous throw, right? So these events are independent. So therefore, we can easily write these events as probability of A complement multiplied by probability of A complement multiplied by probability of A complement multiplied by probability of A into probability of A, right? That's it. In the next case, right, obviously we can say that it is probability of A complement, then probability of A complement multiplied by probability of A and probability of A. That's it. And the third case, we can say a first probability of A, then probability of A complement, then again probability of A complement, then probability of A and probability of A. That's it. So therefore, we can easily write, right, for the first case, probability of A complement is actually repeated 3 number of times and probability of A repeated 2 number of times. And the second case, right, observe that 2A complement, 3 probability of A. So therefore, 2 times probability of A complement whole square multiplied by probability of A, and that will be whole cube. Now observe carefully, these events we already obtained here, 1 by 6 and 5 by 6. So therefore, it will be 5 by 6 whole cube into 1 by 6 whole square plus 2 times of 5 by 6 whole square into 1 by 6 whole cube. So if I take 1 by 6, 3 to 5, so 6 to the power 5 taken common, we write down it as 5 cube plus 2 into 5 square, which gives you that actually 175 divided by 6 to the power 5. And that's why for this particular problem, option A is the correct option. And that's it. Hope you understood the problem. Thank you.
Like, comment, and subscribe. Like, comment, and subscribe.